Hi sir, my name is Xuan and I'll present about the critical evaluation of software testing strategy levels and risk-based testing for the cloud-based University Examination Management System UEMS. The system has suffered real production failures like incurring crash during live exam and security breaches. The presentation follows 6 sections aligned with the assignment brief, each addressing a key testing dimension applied to the UEMS. Let's begin. The UEMS manages the full exam life cycle, from registration, automated grading, and result publication, with 4 user roles. It runs on a DEV OPS CICT model. Critically, it has a documented failure history, like incurring crash, outage during exam, and security breaches. Our role is to propose testing strategy to prevent this from recurring. Why testing is critical for UEMS? Testing for UEMS is a governance obligation. It's not optional. ISTQB states that testing produces objective quality assessment, demonstrate compliance, and reduce residual risk. In UEMS system, failure can falsify academic records and result in legal liability. The shift-left approach in CICT catches defects early when they are cheapest to fix. The previous production failure proved that prior QA was integrated. There are 5 fundamental testing principles guide our strategy. First is passing tests reduce risk. They don't guarantee 0 defects. Second is exhaustive testing is infeasible, so we use techniques like BBA to focus on critical modules. The third one is early testing save costs. Testers must join from requirement phase. The fourth one is defect cluster in complex modules like the grading engine. The last one is CICT. Test suites must continuously evolve as new code paths are added to maintain the coverage. Next is about the unit and integration testing. Unit testing is our first quality gate. The grading engine is the most critical target, covering every scoring rule and boundary condition. Integration testing that then validates component interaction. UEMS system has complex integration points like internal service plus external SIS and identify provider connection. The race condition and data payload errors are key failure modes here. And next is about the system and acceptance testing. System testing covers end-to-end workflow. The stress test must replicate real concurrent exam loads. An independent team should test in a production mirror environment. Acceptance testing is the formal approval gate. UAT confirms user workflow and OAT validates backup and recovery. And contractual acceptance ensures regulatory compliance. The exit criteria must be formally approved before deployment. There are 4 appropriate test types for UEMS. The functional testing validates all requirements across user roles. The performance testing is not negotiable given the outage history, simulating real exam peak loads. The security testing must be continuous. The SAST in builds, DAST on deployments, and penetration testing pre-release. And the last, the regression testing is the CICT backbone, and automate suites that grow with every fix. Next is about the SDLC model comparison. The waterfall isolates testing late, making defects expensive to fix. The agile improves feedback speed but can leave documentation gaps. The DVE OPS with continuous testing delivers agile speed with the automation maturity needed for high-stake systems, making it the only viable choice for UEMS system. Why DVE OPS plus continuous testing is the best for UEMS system? First, UEMS requires frequent policy updates. CICT manages this responsible. Second, performance regression and continuous security scanning directly target the document failure modes. Third, the multi-module architecture suites automate integration testing. And last, the real-time production monitoring provides a safety net impossible in waterfall or agile. Risk-based testing allocates a fault proportional to risk magnitude. There are 5 major risks identified. The first is the grading engine defects. Its critical impact, high likelihood, is the top priority. The security breach has critical impact given proven breach history. The peak log failure mirrors document outage. And next is the test environment infidelity undermines all other testing. The result publication defects carry high institution impact. Prioritization follow aggregate risk. P1. The grading engine get top investment with mandatory completed test passes. P2. Security and peak load reflect proven failure modes. P3. The result publication warrants end-to-end testing and UAT each cycle. P4. Environment fidelity through infrastructure as code underpins all testing validity. And next section is about the test documentation and professional ethics. There are three critical documents. And the first is the test plan. The test plan governs scope and quality expectation. The test summary reports provide objective quality evidence for deployment decisions. And the last, the defect reports ensure reproducibility and formal closure. Ethically, student data must be protected. The grading defects must never be suppressed, and exam content demands NDS and auditable access control. And now we talk about the critical reflection and improvement recommendation. The poor testing has real consequence. Grading error break institution trust, outage disadvantage students, and breaches carry legal liability. Here are 3 recommendations. The first one is the formalized risk-based strategy with cross-functional review each cycle. Second is the production equivalent LSC environments to eliminate environment-specific defects escape. The last one is about the continuous security gates embedded in the CI/CD pipeline. To conclude, we have applied ISTQB principles systematically to UMS. Testing is a governance requirement. A 4-level, 4-type framework targets the system capacity and failures. DEV OPS plus CT is the only adequate model. The risk-based prioritization grounds investment in empirical failures analysis. Documentation and ethics are non-negotiable. 3 targeted improvements address root causes. Ultimately, rigorous testing protects the trust that every student places in this system. And this is all for my present. Thank you for watching.